18. Okay, and then 18 and 23. Are you guys just copying the numbers you see here? Right? Isn't that an easy way to approach it? Right? Okay. These values here for your bin, these are known as bin limits. Now, sometimes, sometimes things that you read are wrong. I'll point that out with the question that we had here already with the book. I even noticed, I put up on the website something known as test your knowledge, okay? What that is if you go to the student lecture, I think it's a student lecture, possibly, I got to double check. Go to the website, there's a test your knowledge, there's a PDF file. That file is questions that were generated from what's known as a test generator. And there's questions and answers, so you can work on some of those questions to test to see where you're at with some of the stuff we're talking about. And then there's a video file that goes over those in detail, those questions. Okay? It goes over the answers. And what I noticed working on it was that test gen actually answered the question wrong. I mean, they gave you the wrong information. It didn't make sense. It said use bin limits, and you actually had to use something else called boundary values, and we'll talk to that. So we'll talk about those things. So what I'm saying is that sometimes when you read this stuff, whether it's a typo or somebody just was snoozing while they wrote it, that can happen. That exists. Okay. Last night working out with my daughter on her homework. Okay. She's being questioned on what's a prime number, going through this exercise, and whoever wrote the question really wrong. It was really bad. So I talked to her about it, and I had to tell her the same thing. It's like, well, sometimes when people write this stuff, they don't really ask, the question really wasn't a good question. It just didn't make any sense with what they had. I understand what they were trying to do, and I pointed that out to her. And so the same thing happens here. So I've noticed that working on that and then answering this question, and we'll talk about it, okay? But sometimes things are wrong, and not all the time. And by this edition, this is the 10th edition, you would hope that they have everything down right, but they don't. It happens. But fine. Okay. These are bin limits. You guys okay with that? Bin limits. I'm going to give you a few more definitions. Definition of the midpoint of a bin. Right? I'll give you this definition, but before I give you that definition, can you guys tell me, how do you find the midpoint? I'm going to put a note. How would you find the midpoint? Or let's say, how do you find a number that is midway between two numbers? Okay, so if I ask you, how do you find a number midway between 4 and 5? I'm sorry, 4 and 6. What would you guys say? You'd say what? Oh, you'd say it's 5, right? Is that right? Some of you guys said 5. I heard it. Now, how'd you get the answer? Some people say, oh, guess what? If I count 4, 5, 6, all right, it's a 5. Okay, you can do that. However, if I say, what's midway between 4 now and 7? That's the new question. What number is midway between 4 and 7? What's the problem now? You guys, if you went with that approach, you go, 4, 5, 6, and 7. And then some people start to say, well, it's 5 and 6. Well, no, because we're asking what number, meaning one number, right? So, although some questions can be approached this way, it's not the best approach, because they can ask you this question, or they can say, what number is midway between 4 and 11,231? Can you now, how do you go about that? Do you know how to find that? How do you find what number is midway? What's the secret? Oh, do you guys know that? How do you guys do that? See, and I'm trying to teach my daughter what a prime number is, right? So how do you guys know that? Okay. Well, should I give you the general form? If they say what number is between A and B, then yes, what you do is you add the numbers and you divide by what? 2. That, in some sense, is finding what we call the middle. Okay? It's the middle of the numbers. Do you guys notice that? Isn't this the average? It's like you're adding the 2 numbers and dividing by 2, right? It's the same concept. So in this case, 4 plus 7 is what? 11 divided by 2 is 5.5. That number is midway between 4 and 7. Okay, you guys okay with that? Similarly, 4 and 11,231, well, add those things. You get 11,235 divided by 2. What do you get as an answer? 5,617.5. Okay? So when I give you the definition of the midpoint of a bin, this is the definition. What do you guys think? How does it feel? The midpoint of a bin. What would you think? A bin here, like this first bin, holds values between 0 and 5. How would you find the value that's midway between 0 and 5? How would you do that? What do you think? What does your intuition say? If I say, what's the midpoint of this bin? You're going to do what? You're going to take the, what's it called? Lower bin limit plus the upper bin limit. Good. Divided by 2. Another tattoo, another definition. All right, you guys okay with that? So what's going to happen now, or what we can determine, is that every bin has an associated what? Midpoint. So here's the deal. What's the midpoint of the first bin? 2.5. How did you get that answer? How did you get 2.5? You added the 0 with the 5. It gave you 5. Divided by 2 is 2.5. Okay, you guys okay with that? What about the next midpoint? What's the midpoint of the second bin? 6 plus 11 is 17. What's 17 divided by 2? 8.5. Good. Midpoint of the third bin. 12 and 17 is 29. 29 divided by 2 is it what? 14.5. And then the next one's going to be a 20.5. And then the next one's going to be a 26.5. How did I do that so fast? Add 6?